Hello everyone, my name is Zihan and my English name is Cameron. And today my final dissertation project topic is using FlamMap 6.0 to simulate the wildfire events in New Zealand. Right, so what is a FlamMap? FlamMap is a fire behavior mapping and analysis software application that computes the potential fire behavior characteristics such as the spread rates, flame length, and the fire line intensity over an entire landscape under constant weather and fuel moisture conditions inputs. And the current New Zealand fire simulator is called Prometheus. So Prometheus is a Canadian wildland fire growth simulation model based on the fire weather index and fire behavior prediction subsystems of the fire danger rating system. Prometheus was reprogrammed to incorporate the New Zealand fire danger rating inputs, field taps, and fire behavior models in early 2010. So in my project, I have done 2 of the case study areas during the past few months, which is the 2019 Pigeon Valley forest fire in Nelson and the 2017 Fort Hills fire. So before we start, a lot of people ask me about, can you model predict the wildfire events? I would say no, it cannot, because it exists a difference between the simulation and the prediction. Simulation computes the model response using input data and initial conditions, and the prediction computes the model response at some specified amount of time in the future using the current and past values of measured input and output values, as well as initial conditions. Right, so the objectives of my project is evaluate the distribution of fire line intensity in different forest types and analyze the fire spread rate in the simulation, which helps on building fire barrier in reality, and determination of the fire length, which indicates the trend of the fire spreading. Cool, so the method. So on your right-hand side, this is the method which is included the topography informations which are created in the ArcGIS. So for this topography information, it has the elevation information, it has the aspect information, and the slope information. On your right-hand side, this is the field model, which contains the canopy cover information and field model, which is like the classification of the local vegetations. And then we can just make a group of the field tab. So these 2 models, the basic model, we can just put into the FlamMap. Right, method. As for method, the first step is building up the first step is building up the topography model, which is done. And the second one is the climate analyzing as one of the important parts of the simulation. Multiple weather data were needed to be collected, such like wind direction, wind speed, air temperature, precipitation, relative humidity, and cloud coverage. And of course, they need to be recorded by different time interval. At this stage, Wind Ninja was used for my weather simulation. And Wind Ninja is a computer program that computes specially varying wind fields for wildfire and another applications requiring high-resolution wind prediction in complex terrain. And wind is also one of the most influential environmental factors affecting the wildland fire behavior. The graph on the left shows the temperature change during the specific data, and all the rest weather information such as the wind direction and speed are showing on the next one. So in this slide, it shows the wind simulation from the Wind Ninja, and this is the specific date simulation for the 8th of this is the 8th of February 2019, which is the 3rd day of the fire events happened in Nelson. And the fire line intensity, so we can see the direction of the wind is 225 degrees at the first, which is indicates to the southwest, and till change to 45 degrees as the northeast direction. And the speed is 6 to 15 miles per hour. So this is the results for the fire line intensity. So what is the fire line intensity? It is to tell the rate of the energy or heat release per unit time per unit length of fire of the front, which is the unit is the kilowatts per meter. So Fire line intensity is a good measure of how likely the fire is to propagate and how difficult it will be stopped. And thus, it is a critical component of the fire behavior models used to inform fire suppression activities, and it's very seldom as fire line intensity actually measured. Rather, it is generally inferred based on flame length, which has been found to correlate with the fire line intensity. So we can see from the photo, this is the simulation of the fire intensity of my case study area in Nelson. And we can see of the major color is the brown color, which is the fire intensity indicates to the legend is 1,731 kilowatts per meter. And we can see the table down there. So to locate the number into the table, which is as a high area, which is has the moderate area, which is between the range 500 to 3,000, which is indicates the maximum flame head, which is around 6 meters, and then the remarks for scorch of complete crown in most forests. And some of the area which is shows around like the dark red color and brown color, which is the high flame line intensity rating, and the fire line intensity is like between 3,000 to 7,000, and the maximum flame head is around 15 meters. And that remarks the crown fires in low forest types, which is something larger than 2 kilometers. And the purple color is located in the really high fire line intensity rating. And the fire line intensity indicates to 7,000 to 70,000 kilowatts per meter. And the maximum flame head is bigger than 15 meters. And what that remarks is the crown fire in most forest types, the forest storm condition at the upper intensities. Right, so this is the results comparison. And on the right-hand side is what my simulation results, which is the fire line intensity results of the case study area. On the left-hand side is the satellite, post-satellite imagery analysis from Interpy. So we can see from the photo, the Interpy has simulated the burn area, which is exactly the area of the Nelson fire. And my one has been simulated as the larger area, because I cropped the DEM model from Land Information New Zealand, which is cropped the big area and which caused the behavior, fire behavior, which is spreading a lot. Cool. So this is the result of the rate of speed. The speed what is the rate of speed? It's the speed with which the fire is moving away from the site of origin. Wind, moisture, and slope drive the fire, and the flaming zone or fire head moves away from the origin quickly with great intensity. So the photo shows that the simulation of the rate of spread of this case study area. And we can see like the majority color is like located into the 1.68 to 3.35. So this means like the rate of spread, the rate of the speed of the rate is around like 1.68 meters per minute to 3.35 meters per minute. And some specific areas around the purple color, which is like 26.2 meters per minute, which just means the fire spreading rate is really fast at the moment. Cool. And this is the result of the flame length. So flame length is a distance measured from the average flame tip to the middle of the flaming zone at the base of the fire. So we can see from the photo. So the color difference tells the difference of the meters of the flame length. We can locate the number into the table, which is indicates to different flame lengths, to different fire line intensity, and to a different description of the fire line intensity, which indicates to the flame length. So most of the area is the yellow color, and the most terrible area, which contains the red and the dark brown color, which is the flame length is bigger than 3.4 meters, and the fire line intensity is larger than 3,459 kilowatts per meter, which is causing the chronic spotting and the major fire runs are probable. Control efforts ahead of fire are effective. Right, so this is the limitation opportunity of my final project. So the limitations is the simulation is only focused on the surface fire. And the elevation model was created by using the 8 meters digital elevation model, and the shortage of the optional input model input such like canopy height, canopy base height, and canopy bulk density. So the insufficient support of the weather information report. And the opportunities which can be improved in the future is the UAV data may use for improving the VEM. Satellite image classification will be more accurate and the more field data to be collected for variant wind model. And a further study could involve the different field parameters. Cool. So final one's the summary. So these models succeeded in the simulation of the surface wildfire events and almost the restoration of fire behavior with limited data resource. Classified the local vegetation's burning attributes, and simulation has investigated various fire parameters. And the fire intensity elevation and the different forest conditions, and examine fire spread rate and fire lengths for the specific area. Cool, that's all for today. Thank you.
Hey, great. Questions for a couple of questions for Zihan.
So is the usage of model, is the use of FlamMap, is it for risk modeling an area, or is it for predicting a spread of the boundary of the fire? What would you primarily use it for?
So sorry, just the question, just to reiterate the question. So is FlamMap intended for like a risk management scenario, or is it perhaps during an actual fire to look at the potential rate of spread and the obviously the flame height and the intensity?
Yeah. So actually, it can be intended to like various use. So as I said, like the FlamMap can be used as to simulate the fire intensity and the rate of spread. So this means like when you simulate the model. So for the in the reality, which can be compared with the model simulation, that means so you can use the model as the predictor, but it's not real predicting. It's kind of like tell you what is the probability of the next step that you can stop the fire or do some like method on that.
Okay, quick follow-up questions.
So I've got a follow-up question. Would you recommend it as a tool for the forest industry, or does Prometheus do the job effectively?
Right.
So the question is Prometheus, which is more commonly known in New Zealand. Would you recommend FlamMap or Prometheus?
Right. So as for Prometheus, I mentioned about the Prometheus software has reprogrammed for New Zealand circumstance, and FlamMap is kind of like a fresh software which haven't been used in New Zealand. So for recommendation, I would say FlamMap is like for I'm doing the things which is closely relates to the accuracy. I wouldn't make any recommend on the accuracy because in my model, which existing maybe coincidence, maybe like a lot of limitations and shortage. So so if I can just combine with all the things that I can get, which is like the shortage of the inputs such like the canopy covers and canopy hats. So maybe combine with all the things together and then make a very accurate model, then will exist a comparison with the Prometheus. So on that stage, I will just recommend as a Prometheus bidder or FlamMap bidder.
Okay. So just to wrap it up, any last question from our Zoom audience? Otherwise, we'll wrap it up at this. We're just a couple of minutes over. Thank you very much, Zihan, for the presentation. Yeah.